We're ready now to look at how trigonometric functions and the unit circle interact. So the first thing we need to note is that on the unit circle, the coordinates of every point x comma y are exactly equal to the cosine theta comma the sine theta. So x is corresponding to the cosine of the angle and y corresponds to the sine of the angle. There are 4 unit circles that we will look at. Here we have a unit circle where each individual wedge describes 1/4 of the entire circle, and so this angle that's shaded here in gray is pi over 2. Here, each individual wedge is 1/8 of our unit circle, so the individual wedge here is pi over 4. Here we have a circle that's divided into 6 equal angles. So this wedge, gray wedge here, is pi over 3. And then we have lastly our circle divided into 12 equal angles, and our wedge here is pi over 6. Let's go back to our pi over 2 circle. Now, it's particularly easy to read off the coordinates of our points at each angle unit. We can see that here we have a coordinate of 1, 0 on the unit circle. Up at the y-axis, the point is 0, 1. On the negative x-axis, it's -1, 0. And on the negative y-axis, it's 0, -1. Now, what do these points correspond to in terms of angles? Well, our starting angle here, the positive x-axis, is the angle theta equals 0. So cosine of 0 is 1 and sine of 0 is 0. Moving on to our first angle of pi over 2, we get cosine of pi over 2 is 0, sine of pi over 2 is 1. Our next angle is pi, and lastly we have the angle of 3 pi over 2. So we can see that these particular angles correspond to the cosine and the sine of theta for the particular theta value. Now remember, this is a unit circle and we can continue on, so we can also label theta equals 0 as 2 pi, and we can go around in a negative direction and say, for example, this theta 3 pi over 2 is the same as theta is minus pi over 2. So I'm just going to show you the base angles between 0 and 2 pi on each of these unit circles, and we can adjust these accordingly depending on what angle we're actually given. Moving on to our pi over 4 circle. We already know this point, so the next point of interest is where the x and the y coordinates are the same, and that is 1 over root 2, 1 over root 2. Now we can use symmetry to note that on this next ray, we are symmetric across the y-axis, so the height or the y value is the same, and our x value is opposite, so we can label this minus 1 over root 2, 1 over root 2. Again, symmetry brings us down here where both the x and the y components are negative, and then either using symmetry across the negative y-axis or symmetry down from the first quadrant into the fourth quadrant across the x-axis, we see that we have a positive 1 over root 2 minus 1 over root 2. So we already know this angle here is theta equals 0. Our first angle that I have labeled here is theta equals pi over 4. We then hit theta equals pi over 2, which is labeled on our first circle. We come to theta equals 3 pi over 4, theta equals pi, theta equals 5 pi over 4, theta equals 3 pi over 2, and then theta equals 7 pi over 4. So now we've filled in, consider overlapping these two circles, we've filled in 8 values. Moving on to our circle with angle pi over 3. We have a 0 here, we won't label because it's on our first circle. If I come up to the pi over 3 value, our x component is short and our y component is long, and we end up with the value 1/2 comma root 3 over 2. Symmetry across the y-axis gives us -1/2 root 3 over 2. Symmetry across the negative x-axis brings it to -1/2 minus root 3 over 2. And then symmetry into the fourth quadrant either through the third or the first quadrant, gives us a half minus root 3 over 2. Now these angles are 0 here for the positive x-axis, pi over 3, 2 pi over 3. 3 pi over 3 I haven't labeled because that's identical to pi, which we have on our first circle. 4 pi over 3, 5 pi over 3, and then back up to 2 pi. Now when we come up to our pi over 6 triangle, we see that we have much smaller angles here. The x component is larger than the y component, and our coordinate on our very first pi over 6 angle is root 3 over 2, comma, a half. So notice this point has the same values in a different order than the pi over 3 coordinate does. Now I'm going to use symmetry, and I'm going to come all the way over here to this particular ray, and I'm going to label this by symmetry as minus root 3 over 2, comma, a half. And then I'll come symmetric down to this ray just below the negative x-axis, and this is minus root 3 over 2 minus a half. Now jumping over into the fourth quadrant, and it's probably easier to see symmetry down from the positive x-axis to this ray here, we have root 3 over 2 minus a half. Now I'm not going to write in any other angles at the moment. Let's just label these particular angles. So theta equals 0 is on our first circle. We get to theta equals pi over 6 right here. Let's count. Pi over 6, 2, 3, 4. Here, our next labeled point is theta equals 5 pi over 6. 6 pi over 6 is exactly equal to pi. So then we come down to 7 pi over 6. Skipping all the way over to our next labeled point, we get 11 pi over 6, so just pi over 6 short of 2 pi. And then we're back up to 2 pi. Now the rest of these angles that are not labeled here are all labeled in other circles that we already have. So remember, I said that this is 2 pi over 6. But 2 pi over 6 can be reduced to pi over 3. So the value for this particular angle can be found by looking at the pi over 3 angle. So you reduce 2 pi over 6 to pi over 3. Same happens here on the positive y-axis. 3 pi over 6 is pi over 2. So we come over to the pi over 2 angle to grab our value. 4 pi over 6 is 2 pi over 3. So we look down at this lower triangle. So those are the special values on the unit circle that we need to be comfortable with.